In this video, we're going to do the last case of special cases, which is naming compounds that contain hydrogen. And so we're dealing with compounds where, let's say, hydrogen is the less electronegative, and it's in the gas phase, so not AQ right now. So for example, HCl as a first element there, HF, H is a first element, HI, H is a first element, H2S is a first element, and they're all less electronegative. H is less electronegative in all these compounds. The point I want to point out as well is that there's no AQ there. So we're not dealing with the acid, we're dealing with the molecular version of this. So we can treat these compounds as being molecular as opposed to being considered the acid. Because again, just to emphasize it, if it was considered the acid, we would name it as an acid and you'd have to see AQ there. But if you don't see AQ, it's the molecular version. And so generally when you have hydrogen, a molecular compound with hydrogen, you usually don't have to use the Greek prefixes. So you can simply say hydrogen sulfide instead of hydrogen monosulfide. You don't have to put dihydrogen sulfide, monosulfide. You can just say hydrogen sulfide, for example. So it just keeps things nice and simple. So let's go ahead and do some examples of that together on our handout here. So if we had, let's say, hydrogen fluoride, to write down the formula for that, you would just do the crisscross really between the hydrogen as H plus and the fluoride as -1, and then you would get HF, and then you would put gas. You wouldn't put AQ because we didn't say it was the acid. We didn't say hydrofluoric acid, so you put gas. So for example, these ones here, this, if it's a gas, you would call it hydrogen iodide. This would be hydrogen chloride as opposed to hydrogen monochloride. So that's just a special case where hydrogen is in the compound as the less electronegative element and in the gas state rather than aqueous. So let's just put that here, not AQ. If it was AQ, you'd name it as the acid. Sometimes hydrogen becomes the anion. So it's a negative charge in your compound. So in that case, it's very similar to naming regular ionic compounds. So for example, if you had, Li2O, it would be lithium oxide. But here we have LiH. So what happens is the H, its fancy ion name when it's the anion, is hydride. So not hydroxide. Remember hydroxide? Hydroxide is OH minus, right? So this is hydride specifically, being the hydrogen in a compound like this. So LiH, for example, would be lithium hydride. So let's say you want to write the formula for calcium hydride. So what you would do is you would just do the crisscross like you normally would. So Ca plus 2, H is our anion in this case, so -1, crisscross it, and you get CaH2. That's calcium hydride, right? Versus calcium hydroxide, which would be this. That's calcium hydroxide, but that's not what we're naming here. We're doing hydride specifically for the formula. Let's go ahead and write the name for this one here. So we have KH. K is potassium. And then the H part is hydride. And so remember, this is basically just like naming any other ionic compound. It's just we had to figure out what the name was for H when it's an anion, and that's hydride. So that is the end of naming compounds with special cases and writing formula for compounds with special cases. You can take a look at some more examples here of how to name and write formulas for the cases with hydrogen. So do make sure you watch the videos throughout this presentation, throughout the slide deck to get some more practice. And then you can go to your worksheets within the learning goals to get some practice there as well. Do be sure that you have your periodic table out so that you can take a look at charges as needed, and also your data tables so you're familiar with where to find polyatomic ions just in case you forget them. And then also don't forget you learn tricks on how to name polyatomic ions or modified polyatomic ions throughout the lessons on naming as well.